Welcome to Chemistry with Dr. Z. I'm Dr. Z, and in this video, I'm going to talk about the difference between elements, compounds, and mixtures. So, an element is made from just one type of atom. And elements can exist as either an individual atom or as a molecule. So, a molecule is a substance that consists of two or more atoms bonded together. So, some elements exist as one atom or individual atom, something like iron, like sodium, and other elements exist as molecules, mostly diatomic molecules, meaning it's a molecules of two atoms of the same type. As long as the two atoms are of the same type, it's going to be an element, not a compound. So elements in general are pure substances that cannot be broken down into any other substance because they only exist as one type of atom and cannot be separated. Atoms of each element can be represented by a symbol consisting of either one or two letters. So you can find the different elements in the periodic table, and each element is represented by a symbol. And the how do we represent it by symbols? Some of these symbols are easy to predict, something like hydrogen as H, something like helium, He, lithium, Li, while other atoms or other elements, they have a symbol that's completely different from its common name. So something like sodium, it's Na, potassium is a K, and so on. So you should familiarize yourself with the different elements and their symbols. And when we represent the different elements, we have to take into account two things. First of all, the symbol of the element consists of when it consists of two letters. The first letter is always uppercase letter. Something like iron, it's an F, which is uppercase letter, and then the second letter will always be a lowercase letter. Um, so you should be able to differentiate between something like CO and CO. Both of them are C and O. The first one, you can see that the C is an uppercase letter, the second letter is a lowercase letter, so this is an element, this is called cobalt. The second one here, or the second sample, you can see that there is a C, which is an uppercase, and O, which is an uppercase. In this case, this is not an element. This is a compound consisting of two different elements. The first one is C, which is carbon. The second one is O, which is oxygen. So this is carbon monoxide. This is a compound, not an element. When you represent the element as well, you have to take into account the form of its existence, whether it's an individual atom or is it a molecule. So the elements here you can find they all exist as individual atoms. So iron, sodium, potassium, magnesium, helium all exist as individual atoms, while there are other elements which exist as molecules. So, for example, hydrogen, which exists as diatomic molecule. So we write the letter two, the number 2 next to the hydrogen, and then we also have nitrogen, oxygen, and something like chlorine. All of these exist as molecules. So you need to write correctly the symbol and the form of existence of that particular element. So what about compounds? So compounds consists of two or more different atoms which are chemically combined. So the whole idea is being two or more different atoms and they are chemically combined. So when elements react together, they form compounds. So compounds are formed by a chemical reaction. A compound or different compounds are represented by a chemical formula. In the same way as we represented the elements, whether they exist as individual atom or a molecule, compounds will always exist as molecule because they are formed of more than one atom. So they are represented by a chemical formula that reflects the number of each element within a compound, because compound is formed um, by a chemical combination of different atoms in fixed proportion. So the chemical formula will represent that fixed proportion, not just the proportion between the different atoms, but the how many atoms exactly exist in that particular molecule. For example, when we write CO2, which is carbon dioxide, that means this is the chemical formula for carbon dioxide. That means that each molecule of carbon dioxide actually consists of one atom of carbon, two atoms of oxygen. Water, H2O, there are two hydrogens, one oxygen. When we have FeS, iron sulfide, this is one atom of iron, one atom of sulfur. The properties of the compound is different from the properties of the atoms that form that compound. So a typical example of that is iron sulfide. So iron sulfide is formed by a chemical reaction between iron and sulfur. And we know that iron is a metal and it's magnetic, while the compound iron sulfide that has been formed is non-magnetic. So the properties of the compound is different from the properties of the different elements that form that compounds. Atoms within the compounds cannot be separated by physical processes because they are chemically combined, and if they are chemically combined, they cannot be separated by physical processes. And examples of the physical processes are the filtration, crystallization, distillation, and so on. So you cannot use these processes to separate the different components or the different atoms um, uh, in a compound. So what about mixtures? So mixtures are formed when two or more different elements or compounds are mixed together. So the main idea is having different elements or different compounds or a mixture of compounds and elements, and they exist together in the same vessel. They are not chemically combined. So the whole idea is they are mixed, they exist together in the same place or in the same vessel, but they are not chemically combined. A typical example of a mixture is air. So we know that air, you can find gases, different gases in air, like nitrogen, like oxygen, carbon dioxide. We have argon as well, and we have water vapor and other gases. So this is a mixture of different elements and compounds as well. Because the different components of the mixture are not chemically combined, they just exist together in the same place. So the properties of the mixture is actually a mix of the properties of all the different components of that mixture. Um, the Each component of the mixture retain its chemical properties even when it's part of that mixture, so it doesn't actually change. If it undergoes a certain reaction, still going to do this reaction or take part in that reaction even when it's part of a mixture. And because the different components of the mixture actually are not chemically combined, they can be separated by physical processes. And in the description of this video, you're going to find a link to another video explaining the different physical means or different physical processes that we use to separate the different components of the mixture.